Here is a short video on how to fill out the application data sheet for clamp-on for non-hydrocarbon, non-gas applications. The first bit that you're going to fill out is something about who this is for and who's requesting it. And the second part is the PIA selected part number that you're going to come up with when you open PIA and go into the PIA selector. The first thing you're going to go into is the product number, and it's either going to be for a 3723 or a 3570. $37.45 would be for a portable. Once you come up with a part number that you think will work for your customer, you're going to put that number in here, beginning with 7ME. You're going to, in this section, tell us something about the liquid, which would be the liquid type, if there's any solids or gases, and if so, what the percentage by volume are those solids or gases. If they are solids, you want to list down what is the particle size. Back in PIA, what you can do is go into the compatible applications, for a rundown of what would be compatible with our meter. I can give you an example here. Let's find one. And here we have selected beer, and you'll notice there's a number of meters that we know will be compatible with typical beer as a liquid. So you want to put in the liquid type, and what's very important is you want to put in the temperature range so we can select for you the appropriate temperature range sensors. Pressure is less important. If you know the viscosity or density, you want to enter it in on these two lines. Pipe data is also critical, and the reason for this is that we need to know what the outside diameter and pipe material is so we can come up along with wall thickness so that we can come up with the appropriate sensors for the application. If you know that there's a liner, please add that information along with the liner thickness. If you're talking about steel pipes and PVC, you can go ahead and put in a pipe schedule. What you don't want to do is mix terminology between different types of pipes. For instance, we often get application data sheets that have ductile iron listed as the pipe material, and then they also list Schedule 40 as the pipe schedule, which has nothing to do with ductile iron. Ductile iron goes by material class rather than pipe schedule. But the best bet is to put your outside diameter, material, and the actual wall thickness. That would be your best bet. Go ahead and provide for us how much straight run you have on the pipe, and if it's less than 2 diameters, give us that distance or dimension in inches so we know that we have enough room to mount the mounting hardware onto the pipe or not. That's also echoed here with the length of unobstructed pipe, either in feet or meters. Um, what's the pipe orientation? Does it run horizontally, vertically, or inclined? If it's vertical, it would be a good idea to write down here if it's upward vertical or downward vertical, as downward vertical would oftentimes be problematic. We'd also like to know that this is a full pipe or a partially full pipe or something in between. As for the flow sensor data, we'd like to know if this is a submersible application. Check also if it's dedicated or if it's portable. And we'll know about the high temperature from the liquid information that you provided above, but you can also check it here. We'd also like to know if you want to use, if the customer would like to use stainless steel enclosures or would aluminum suffice. Let us know if the sensors will be located in or outdoors. And very important, will this be in a hazardous area? If it is in a hazardous area, please select FM and tell us what area and classification the transducers will be put into. The RTD information is less critical because most of the time there will be no RTD or temperature sensor for standard liquids. For hydrocarbons and gases, there certainly will be, but for water and other liquids, ordinarily there would not be, unless this meter was being paired up with an energy calculator, such as an FEC 920. Cables, we'd like to know if the cables, we would like to know what the distance is between the transmitter and the sensors ultimately, and what type of cables. You can put down here armored if they definitely need armored cables. Otherwise, we will be supplying submersible cables. We would also need to know if the transmitter will be in a hazardous area, and also what would that area classification be, whether it's Class 1 Div 1 or Class 1 Div 2. That'll help us in determining what the transmitter type should be. If it's an FS230, we don't need to know the input power, as that's field swappable between low power and high power. If it's an FST020, then we need to know if it's standard 110 volts AC, or is it low power AC or DC. As far as the communications, you don't have a choice for an FST020, but you do have a choice if it is an FS230. In PIA, when you get down to the input-output configuration for channel 1, if you're configuring for an FS230, you have to determine what to select here, whether it's HART or Modbus. If it's HART and it's a non-EX application, you can select EO2. And therefore, it can be field swappable for active and passive without changing any of the hardware. However, if it's an EX system and you want HART, you need to decide up front whether it's going to be EO6 for active HART or EO7 for passive HART. As far as Modbus is concerned, it's only one selection, whether it's an EX application or a non-EX application. And of course, if none of these are necessary, you select E00. Now, channel 2, 3, and 4 are a little bit different. You can go with no additional inputs or outputs, or if it's a non-EX system, non-FM, no approvals, it's going to be the F01 through the F06 selections. So 01 through 06 will be for non-EX applications only. If it's an EX application, you have to choose between F11 and F26. And just realize that the first half of these, from F11 to F16, will be passive only outputs, and then from 21 through 26 will be active only outputs. Active versus passive does not apply to the relay. The relay is just a contact closure. So once you've finished with the outputs for the meter and the temperature range that the transmitter will be in, the only thing left is to decide what the accuracy is required. If the customer decides that he needs to be within a certain accuracy. Otherwise, just know that the standard cut sheet accuracy will apply depending on the meter you selected. And that's pretty much it. Thank you.